Anywhere in the vicinity of an electric charge, a small test charge experiences a force. If it's due to only one charge, the pattern of forces detected by the test charge is simple. The pattern's more complex for two opposite charges. Or for two charges of the same sign. And more complex still, for more complicated arrangements. But in any case, here's the point. Even if the test charge isn't there to feel it, the pattern of forces can be imagined to exist everywhere in space. This is the essence of the idea of the field. And although Faraday only imagined it, the field can also be expressed mathematically.
The force that acts on a test charge at each point in space is equal to the test charge times a quantity due only to the other charges. That quantity is the electric field.
Faraday never arrived at that definition of the electric field. But by seeing both electric and magnetic phenomena as forces in space, he managed to see further than his peers. As a result of this, and many other discoveries, he eventually became director of the research laboratory at the Royal Institution. And succeeding Davy, he became the professor there, as well as a member of the Royal Society. But it was as researcher, rather than instructor, that he saw deeper and deeper into the invisible forces of space. To Faraday, the 1/r² force between electric charges suggested that the force must be applied by something radiating outward from charges, something which, like light from the sun, never stops and never ends in space. As Faraday imagined it, this something would be lines or tubes, each one capable of applying a force to any charge in its path. These lines of force would begin only on positive charges and end only on negative ones. And they would flow smoothly through space, never crossing or tangling. No matter the configuration, the charges would have a characteristic pattern of lines. The force they applied would be strong near the charges where the lines are crowded together, and weak far from the charges where the lines are farther apart. The ability to apply a force resides at each point in space, and the force arises from the intensity of lines, regardless of the location of the charges that create them. Even without such space-age graphics, this is how Faraday pictured the electric field. And it still seems the most graphic way to visualize one. But satisfying the scientific community would take another step or two.